All right, so part 3 is all about dividing rational expressions. So remember, everybody has different words whenever I've heard them all. Well, I thought I had until yesterday. But my favorite way to remember how to divide fractions is the following three words. So keep, change, flip. So that means, I'll just do one. So you keep the first fraction, 6/5, change it to multiplication. I'm going to use the dot because we're going to have x's coming up later and I don't want to get confused. So keep, change it to multiplication, and flip the second fraction. Okay, so now that you've done that, it's just one little step, and then you're ready to do a multiplication problem just like we were doing in the last video. So we would, looks like here the 5s cancel diagonally. They just cancel out altogether, perfect. And then the 6 and the 3 become 2/1. So you have 2/1 or just 2. Okay, same thing for the next one. We're going to keep it 21/8, change it to multiplication, and flip the second fraction. Cross simplify, so that becomes 2, this becomes 1. You can divide both of those by 7, so 3 and 1. So you end up with 3/2, or 3/2. One more. Keep it, change it, flip it. Okay, so 12 and 6, you can divide both of those by 6, so 2 and 1. 25 and 35, you can divide both of those by 5, so that becomes 5 and 7. So you end up with 5/14. Okay, now can you do the same thing with binomials? And the answer is absolutely. So keep, so that stays the same. I'm going to drop the parentheses because they're not doing anything. Change it to multiplication and flip that second fraction. Okay, remember your rules. You can cancel out the x plus 2's. Can I cancel or reduce the x plus 6 and the x plus 3? The answer is no, because they are binomials, so you have to leave them. So you end up with your answer being x plus 6 over x plus 3, and parentheses are optional. If you like them, put them. Next one, so we're going to rewrite it. Some of you will try to take shortcuts and not write it, and I'm telling you, you're a lot more likely to make a mistake. So just take the couple seconds and rewrite it, flip that second fraction. You're fine. Okay, so what do you see? I see x plus 2 and x plus 2, x plus 1 and x plus 1. Looks like there's 2 x plus 3's on the bottom. You can only cancel, and 1 on top, so that means you can only cancel out 1. It doesn't matter, pick one. I'm going to pick this one just because they're closer together. I don't know. Doesn't matter. So those cancel. So you have, all that's left is x plus 7 over x plus 3. Parentheses are optional. All right, same thing. We're going to rewrite it. So keep it. It's getting kind of long. Change it to multiplication and flip. All right, so what do you see? I see x minus 2's here, x plus 2's here, x plus 6's, and I think that's it. So we have x minus 5 over x minus 1. There you go. Okay, getting a little bit trickier here. Same thing. So 4x squared over x plus, 4x squared times x plus 6 times x plus 2 over x plus 2 times, gotta flip it. So now it's 12x to the 5th over x plus 6. Okay. What do you see? So I see that x plus 6's. Cool. One set of x plus 2, right? Doesn't matter which one on top. Just pick one of them. And now let's talk about the numbers. So 4 and 12, you can simplify both by 4. So that's 1 and 3. Let's do that in a different color. So let's do 4 is 1, 12 is 3. And then the last one I think that we can simplify is your x squareds and your x to the 5th. So we have x squared over x to the 5th. What's the most amount you can cancel? Since there's 2 on top and 5 on bottom, the most you can cancel out is 2. So all of them on top cancel, and on the bottom you're left with 3, so that would be x to the 3rd power. All right, so what do you have left? Looks like all that's left on top is x plus 2. You can write that 1 if you want, it's optional, but if you do that, put parentheses around the x plus 2. And then on the bottom, it looks like 3x to the 3rd is all that's left. Okay, 2 more. So we have, let's keep it, so x minus 3 times x plus 3 over 5x to the 7th times x plus 1 times, flip it. All right, I know I'm going kind of fast, so pause it if you need to. So I'm going to cancel, looks like x minus 3 cancels. The 5 and the 20 cancel, so that divide both of them by 5, so that becomes 1 and 4. And then your solo x's out front cancel, so you have 11 on top and 7 on the bottom. So that means 7 of them cancel. So all of them cancel on the bottom, and you're left with x to the 4th in the numerator. Okay, I think that's it. So let's put it all together. So we have 4x to the 4th over times x plus 3 times x plus 2. And notice I put this number out front because that's kind of math etiquette you do. If you put it in the middle or to the end, it's okay, but it just doesn't look very nice. So try to put it out front if you remember. And then on the bottom, you just have x plus 1, I believe. All right, so there's your answer. And then last one. So I'm going to rewrite it, not be lazy. So I have x plus 1 times x minus 1, 5x to the 6th y, x plus 1 times, flip it, then you have x plus 2 times x minus 1. All right, so now, what do you see? I see x minus 1's cancel, x plus 2's cancel, oh sweet, and x plus 1's cancel. Cool. 2 over 5, you cannot reduce that. Looks like my x's, I have 4 on top and 6 on the bottom, so it looks like 4 cancel, so all on top, and you're left with 2 on the bottom. And then y's, let's see, 3 on top, 1 on the bottom, so you can cancel out 1. Oops, sorry, let's do a different color. All I have is black left. So 1 on the bottom, and that turns into a 2y squared. All right. So it looks like all we have left on top is 2y squared, and on bottom, 5x squared. Can you simplify any further? Nope, because you can't reduce 2/5 and you can't do x's and y's, so that is it. All right, that's it. Thanks for watching.